Hey everybody, and welcome to this video on adding and subtracting radicals. So let's get this show on the road. Alright, let's try adding and subtracting some radical expressions and see what happens. For instance, 2 times the square root of 5 plus 8 times the square root of 5. Now, I bet if I'd given you a slightly different problem like 2a plus 8a, you'd probably have no doubt in your mind that the sum was 10a, and you'd be absolutely right. The variable a represents some number. We had 2 times that number, and then we added 8 more times that number for a grand total of 10 of that number. Well, here we have the exact same thing. I'm not sure exactly what the square root of 5 is, but it's a number. We've got 2 of them to begin, and we add 8 more to that for a grand total of 10 square roots of 5. Let's try another. How about 4 root 2 minus 9 root 2? Same idea. I'm sure if I gave you a very similar problem like 4x minus 9x, you'd have no doubt in your mind that the difference was negative 5x. X, this variable represents some number. And the square root of 2 is also some number. I don't know exactly what it is, but it's a number. So we've got 4 times that number minus 9 times that number for a grand total of negative 5 times that number. Now what happens if those radicands aren't the same? So for example, 6 times the square root of 3 plus 2 times the square root of 7. Here, things look a lot less straightforward, and we might be thinking, how do I add these? Well, we can't. This is just like saying add 6x plus 2y. And what is 6x plus 2y? It's xx plus 2y. There's nothing more we can do with this. We can't combine them anymore because x and y, whatever those variables are, whatever numbers they represent, they're not the same number. It's literally apples and oranges. Well, in this problem, it's the exact same thing. The square root of 3 is some number, and the square root of 7 is also some number, but they're not the same number, so there's no way to combine them. There's nothing more we can do with this. We just leave it as 6 root 3 plus 2 root 7. So let's make a quick note. In order to add or subtract two radical terms, each root must have the same radicand. The thing inside of the root has to be the same. All right, let's try another. And note that in every example we've done so far, we've had a square root and a square root. What happens if we have a square root and a third root, like in 4 times the square root of 5 minus 6 times the third root of 5? Now note, we do have the same radicand here, because 5 is the number inside of both radicals. But something still seems a little off. Like in our last example, we're not going to be able to subtract these. There's nothing more we can do. This is kind of like saying, please subtract 4y minus 6y squared. Both of these terms involve the same variable y, but one has a y squared and one has just a normal y to the first power. And even though we don't know what y is, we do know that y and y squared are different numbers. So we can't combine the two. Similarly, in this example, the square root of 5 and the third root of 5 are not the same number. So we can't combine these two terms at all, and there's nothing more we can do. So let's make another note. In order to add or subtract two radical terms, each root must have the same index. It's got to be the third root and the third root, or the square root and the square root, or the fourth root and the fourth root, or whatever it may be. So if either of those two things, the radicand or the index, are not the same, then we cannot add or subtract those radical terms. All right, now that we got those examples under our belt, here are 4 more problems that I'd like you to try. So why don't you pause the video and add or subtract these radical expressions. And if for some reason you can't add or subtract them and simplify anymore, you can either leave it as is or you can say, can't simplify anymore. All right, why don't you give them a try? All right, let's try a few more. Now when I look at these, I see that in the first example, we have the same index. It's a square root and a square root, but our radicands aren't the same. One is the square root of 2, one is the square root of 8. And same thing in our second example. We've got the same index, we've got a third root and a third root, but again, our radicands aren't the same. We have the third root of 16 and the third root of 54. So at first glance you say, well, there's nothing we can do. We can't subtract these. But when I look at, for instance, the square root of 8, something tells me that we can simplify this. And indeed we can. We can rewrite the square root of 8 as the square root of 4 times the square root of 2. And the square root of 4 is a nice number. That is 2. So in our original example, when we're subtracting 3 times the square root of 8, that's the exact same thing as subtracting 6 times the square root of 2. And then you see that our original problem can actually be rewritten as 5 times the square root of 2 minus 6 times the square root of 2. We got the same index, we got the same radicand, we can go ahead and subtract these. And we end up with negative 1 times the square root of 2, or just negative the square root of 2. So even if our radicands aren't the same, if we have the same index, you should look to see, is it possible to simplify one or both of these radical expressions to then have a problem where we have the same index and same radicand, and then can go ahead and add or subtract. Let's try another one. In this case, of course, yes, we have the third root and the third root. The index is the same. Great, but the radicands aren't. But I think that we can simplify both the third root of 16 and the third root of 54. I think we can rewrite the third root of 16 as the third root of 8 times the third root of 2. And I think we can rewrite the third root of 54 as the third root of 27 times the third root of 2. And what's so nice is that the third root of 8, that's a very nice number. That's just 2. And the third root of 27, that's also a number. That's just 3. And so our original problem, once we've done some simplification, actually turns into 8 times the third root of 2 minus 6 times the third root of 2. And now we've got the same index, we've got the same radicand, we're ready to go. We end up with 2 times the third root of 2. So again, in this case, it originally didn't look like we could subtract them, but once we did some simplifying, we could. All right, now that we've got those examples under our belt, here are 2 more where it seems like we have the same index for the first, they're both square roots, the same index for the second, they're both third roots, but the radicands don't appear to be the same. But if you simplify them, you should be able to add and subtract. So why don't you pause the video, take care of these 2, and when you're done, play the video, and we'll see how it went. Alright guys, that's it for this video. I hope you found it helpful, and I hope you enjoyed.